Hello, everyone. In today's session, we will delve into the fascinating world of observability in modern treasury trading platforms. These systems, which handle vast amounts of market data and execute trades in microseconds, face immense challenges when it comes to maintaining performance at scale. As the complexity of high frequency trading increases, traditional monitoring solutions are no longer sufficient. Through this discussion, we will explore how advanced observability tools like distributed tracing, machine learning, driven anomaly detection, cloud native observability pipelines are transforming how we monitor. Let's dive into how observability is revolutionizing high frequency trading and shaping the future of treasury operations. I'm Ganesh Marimuthu, and senior with over 23 years of experience in the investment banking technology domain, specializing in delivering high performance, cost effective technology solutions tailored to meet complex business needs. Hands across fixed income trading, risk management, regulatory compliance, client reporting, and having worked with industry leading products such as Ion, Fidesa, SunGuard, Fast, InTrader, and specialized needs like Wall Street, which is a product of Ion. I have involved in design, development, and optimization of algorithmic trading strategies that leverage advanced quantitative models and market data analytics. My work includes implementing high frequency trading algorithms, market making strategies, trading strategies that have significantly improved trade execution efficiency and profitability. My product knowledge or experience encompasses a diverse range of financial products, including US Treasuries, be it Swift messages or ISO related packs or messages. I have extensive experience supporting all of them. Throughout my career, I have built reputation for managing, designing, and optimizing advanced technology infrastructure. That's deep dive into how this observability is revolutionizing high frequency trading and shaping the future of how treasury operations will be. Observability in modern treasury trading platforms. So, drawing from my experience building trading infrastructure at major financial institutions, I will share how modern observability practices are revolutionizing operations in systems where reliability directly impacts the financial outcome. Today, we will examine how observability solutions monitor systems processing 8.4 terabytes of market data daily with algorithmic engines, 2.5% of treasury trades at speeds of 145 microseconds. Unbelievable amount of data that is being join me as we dive into the technical components that enable this remarkable performance and reliability scale of the modern treasury trading. More than 8.4 terabytes. We recently implemented database using KDB, which used to process about 300 to 600 million a day for several dealer to dealer markets. 82.5% of algorithmic trading, percentage of treasury trades executed by the algorithms. We also try to integrate smart order router, which process more than 75% in few of the exchanges, famous ones like NASDAQ and broker dealers, and these are the exchanges. The execution is one rich latency for trade. 185K messages per second. That's the throughput of market data in the peak conditions. The sheer volume and velocity of modern treasury trading creates unprecedented observability challenges with microsecond level decision making and execution. Traditional monitoring approaches simply cannot. These systems operate at a scale where even minor performance degradations can result in significant financial impact. Moving on to the next slide. So, distributed tracing in treasury trading. So basically, this is the MT mean time to resolution or repair resolution. Implementation of distributed tracing across trading microservices has DTR by 78%, enabling faster incident response in critical trading operations. End-to-end visibility. Traces now connect across previously siloed components, providing transparency from market data engine. Very key for locking the trades, where you place an order and it has to get filled to get the right match. Trace analytics, identify bottlenecks in the trading pipeline, allowing for targeted optimizations that have improved average execution times by 23%. Low tracing adds less than 2.5 microseconds of overhead, maintaining critical performance while providing observability. Distributed tracing has transformed troubleshooting in treasury trading platforms, enabling teams to follow transactions across complex, massive microservice architectures without compromising performance. What anomaly detection, machine learning. So our ML powered anomaly detection systems that achieve 85% accuracy in identifying trading pattern deviations. This capability has prevented millions in potential trading losses by detecting market dislocations, execution anomalies, compliance issues before they impact trading outcomes. The system continuously learns from both normal operations and detected anomalies, improving detection accuracy over time while maintaining performance under. So, as the diagram illustrates, real-time pattern recognition identifies market anomalies within microseconds. The historical baseline comparison compares current to normalized patterns, false positive reduction, self-tuning algorithms minimize alert, automated response actions, triggers predefined safeguards. So here I want to touch upon the need for observability for trade surveillance and spoofing. In this fast evolving landscape of treasury trading, the need for robust trade surveillance and observability has never been more critical. With high frequency systems executing thousands of trades per second, the ability to monitor and track every transaction in real time is essential for ensuring market integrity, regulatory compliance, and risk mitigation. Trade surveillance systems identify potential market manipulation, fraud, or compliance violations, while observability tools provide end-to-end visibility into the trading process, allowing firms to detect anomalies, optimize performance, and minimize latency. The integration of machine learning for anomaly detection combines market activity and the system health. This powerful combination ensures that trading platforms are not only operationally efficient but also compliant with evolving regulations. In modern treasury trading, observability goes beyond just monitoring. It is a proactive approach that helps organizations detect potential issues before they affect the trading outcomes, ensuring that systems can continue to operate at a scale with the utmost reliability and security. Moving on to the next slide. Cloud native observability pipelines. So today we have Amazon's web services. Today we have a GCP. We have so our cloud native observability pipelines have transformed treasury trading monitoring, increasing capabilities by almost 30% while reducing operational costs by 42%. These pipelines process over 36 million metric data points per minute, enabling real-time visibility across global trading operations. By separating collection from processing and storage, the architecture maintains a resilience during market volatility when observability becomes most critical. Depends on all these like data collection, processing, enrichment, storage, and indexing, visualization, and alerting. So by data collection, the ingest metric logs traces from the trading system at source, process enrichment like using data with business metadata and reducing the noise, storage, optimizing for both real-time queries and historical analysis. KDB, the tick database, or MongoDB, the NoSQL database are completely efficient and effective for such observability pipelines. Moving on to the next slide. Smart order router integration. As the word in the algorithmic trading, where be it the dealer to dealer or a dealer to client market, the algorithm or the smart order decides how the order would get routed based on the algos, and it smartly detects and allocates the fills that is required by the trader. Round trip measurement, time measurement, continuous monitoring of order transmission and acknowledgement latency, venue responsiveness, measuring performance variations between trading destinations, slippage analysis, real-time comparison of expected versus actual. This is very key because sometimes the smart order router may or may not execute at the desired fill for that particular instance which the desk wants. So the real-time comparison of the expected versus actual execution prices is very critical, which has to be observed. This integration creates powerful feedback loops that continuously optimize order routing decisions based on real-time performance data. Our implementation has improved overall execution quality by 17% while reducing adverse selection by monitoring venue-specific patterns that might indicate information leakage or toxic flow. Moving on to the next slide. So this is basically the system latency variations that is described here, where the heat load is shown by the light orange and baseline latency in the red. The Treasury trading systems experience latency variations of up to 20% under peak load conditions, particularly during the market openings, economic announcements, auctions, any key IPOs that go online. Observability solutions must adapt to these variations without introducing performance penalties. In this, if you notice, at 9 a.m., 9:30 a.m., the peak volatility latency is shown. During the noon, it has gone down, and during the market close, it has quantum computing advances threatened traffic protections. Treasury trading platforms are implementing quantum resistant approaches to monitoring. These techniques ensure the sensitive trading data remains secure even as cryptographic standards evolve. The early implementations have demonstrated that quantum resistant approaches can be integrated with minimal performance impact while providing future proof security guarantees. Homomorphic encryption, enabling analysis of encrypted metrics without decryption, maintaining privacy while allowing alerting on sensitive trading data. This technology supports compliance with data protection regulations while quantum random number generation, leveraging quantum in approach, implementing lattice-based cryptographic algorithms to secure monitoring data against potential quantum attacks. These algorithms ensure that today's encrypted observability data remains protected against decryption. This is the post-quantum crypto. Moving on to the next slide. Blockchain-based audit systems. Blockchain-based audit systems are transforming treasury market infrastructure by creating the immutable records of all trading activity. These systems have reduced reconciliation costs by 82% while providing near real-time settlement visibility across counterparties. Integration of observability data with blockchain records creates powerful new capabilities for regulatory reporting, compliance monitoring, allowing for automated detection of potential market manipulation or trading rule violations. So real-time settlement visibility, transparent tracking of trade life cycle. Trade life cycle is the key. Backend trade through processed trades will impact the trader's books, which may or may not be found out until the end of the day. So this is very critical. Reduced reconciliation needs, single source of truth across counterparties, enhanced compliance monitoring. Compliance and regulatory are becoming big. All these FINRA, ISO, all the other standards are becoming really big. So automated regulatory reporting. And as I mentioned earlier, immutable audit trail, cryptographically secure transaction record. So what are the challenges in observability? Performance impact, data volume management, signal versus noise. So observability instrumentation adds overhead that can affect trading latency. Solutions include strategic sampling, branch circuit monitoring, designed specifically for ultra low latency environments. Data volume management. Treasury systems generate terabytes of telemetry data. Processing this volume is in real time queries, sophisticated pipelines, and storage solutions optimized for time series data. Effective implementations use tiered storage approaches with hot data kept in memory and cold data automatically archived cost-effective storage while maintaining query capabilities. KDB, which I explained a couple of slides earlier, was one of the key big databases which we have implemented in the past that has proven to mitigate such data volume management. Advanced correlation contextualization techniques combined with machine learning help identify truly actionable insights among the noise of normal market fluctuations. Addressing these challenges require a balanced approach that considers both technical and business requirements. The most successful implementations align up these strategies with specific trading. So, what are the map and conclusions? The future of treasury trading observability lies in the intelligent systems that not only monitor but predict what the impact trading. Organizations, especially the financial organizations that mark these capabilities, will gain significant advantages in efficiency, compliance, and ultimately profitability. So, assessment phase, then comes the architecture design, develop observability framework that minimizes performance impact, progressive implementation, deploy instrumentation in phases, validating performances at each stage, and continuous optimization, refine based on operational insights and evolving trading patterns. The mean time to measurable behavior quality, lower operational cost, and enhance risk management. As market complexity increases, ability becomes not just an operational advantage, but a competitive necessity. And that's pretty much it. We conclude this presentation. Thank you for taking time to listen to this presentation. And if you have any questions or any suggestions or any recommendations, do reach out to me on the contact details provided in